Hey guys, so this is the new Unit 7, solving trigonometric equations with identities. And trigonometric identities are basically different ways to express trigonometric functions. I know you know that trigonometric functions can be written in so many different ways. For example, secant of x can be written as 1 out of the cosine of x. Tangent is sine over cos. Cot is 1 over tan, which is the same thing as cos over sine. So these equations involving these functions or involving trigonometric identities can be solved by figuring out what way of writing this trigonometric function can I use to solve the equation. You're going to see what I mean in a second. So before we start, just a recap. Hope you remember that cosec is this cosec is 1 out of sine, sec is 1 out of cos, cot is 1 out of tan, but can be simplified to cos, because 1 out of tan, that's the same thing as 1 out of sine out of cosine. So if you do KFC, that's the same thing as 1 divided by sine divided by cosine, and I'm taking time on this because in the future I'll just say cot is cos over sine. So this becomes 1 times cos divided by sine, and I hope you can see that cot is basically the same thing as cos theta divided by sine theta. Because it's a reciprocal of tan, it makes sense that it's cos divided by sine, because we know that tan is the same as sine over cos, so therefore cot is simply the reciprocal of this, therefore cosine over sine. Oh yeah, there it is. Cot is also cosine over sine. Now I hope you remember that we used Pythagoras theorem to find this first identity, and we found that it was equal to 1. If you don't remember, you can try to go back to a triangle like this, in which this angle is theta, if this is x, and that is y. You can call that z or r if it's a circle, when it's the radius of a circle. But if you have that triangle, the sine of theta is y over z. The cosine of theta is x over z. And if you look at that triangle, since it's a right angle triangle, if we apply Pythagoras theorem, then x squared plus y squared is equal to z squared. So if I substitute for these functions, from this function that sine theta is equal to y over z, I can see that y is equal to z times sine theta when you cross multiply. Let me do that slowly because it's important that you understand the beginnings before we get into the deeper applications of these identities. So this is over 1. I'm going to cross multiply. Y is equal to z sine of theta. Cross multiply this one too. X is equal to z cosine theta. Z or z or whichever one makes you happy. So if I use Pythagoras theorem on this triangle, Pythagoras theorem says x squared plus y squared equals z squared. If this is a and that's b and that's c, then a squared plus b squared is equal to c squared. Now I've seen from here, from that expression, that x is the same as z cos theta. So instead of x, I'll replace it with z cosine theta. Replace x with z cosine theta, so that will be z or z cosine theta. Everything is squared. Y is the same as z sine theta, so I'll replace y with z sine theta. Everything is squared, and this is supposed to equal z squared. If I put the square inside the brackets on both equations, then I'll have z squared cosine squared theta plus z squared sine squared theta is equal to z squared. I hope you can see that the z squared is common to all of them, so I can either just cancel it out or I can divide each term of this equation by z squared. And if I divide each term of the equation by z squared, then z squared will cancel out. So when z squared cancels out, I'm left with cosine squared theta plus sine squared theta is equal to 1. So this is the very first Pythagorean identity of trigonometric functions. And this we talked about this in some lesson. I don't remember which lesson it was. We talked about it before. I just wanted to touch base on it again. So this is the first identity. It's called the Pythagorean identity. From this first identity, we can get these others. We can get this and this one. How do we do that? By simply eliminating either cosine or sine from this equation. So if I want to eliminate cosine from this equation, because it's cosine squared theta plus sine squared theta is equal to 1, I can divide each term of the equation by cosine squared theta. When I divide each term of the equation by cos squared theta, that will give me 1, right? Here I have sine squared divided by cosine squared. Well, I know that sine out of cosine alone is tan, but if each of them is squared, then that becomes tan squared. I know that on the right hand side I have 1 out of cosine squared. That's the same thing. 1 out of cosine is secant, and 1 out of cosine squared is secant squared theta. So that's the second identity. Oops. Yeah, that's the second identity. In this order is the third, but yeah, these three are trigonometric identities. Second or third doesn't really matter. All matters is tan squared theta plus 1 or 1 plus tan squared theta is equal to secant squared theta. It's going to take you a while to get used to these ones, but I just want you to remember this one mostly, because from this one you can get these two. You can derive these two. If you eliminate cosine, you get the tangent one. If you eliminate sine, you get the cosecant one. That's what I was going to show you here. If I do this again, but instead of eliminating cosine, I try to eliminate sine. To eliminate sine, I'll divide both sides by, each term of the equation by sine squared theta. Sine squared theta. So I'll have cos over sine. Remember, cosine over sine is cotangent squared theta. Sine over sine is 1, and 1 over sine is secant squared theta. So those are the three Pythagorean identities that I just have been talking about. Again, emphasizing the one that is very important for you to remember is this one. It's quite easy to remember because sine squared theta plus cosine squared theta is equal to 1. It's something you can remember. Even make a tattoo of if it's hard for you to remember. I suggest you put the tattoo on your palm, maybe, so that we can tell if you're cheating on an exam. But anyways, from that first one, you can get these other two. Those three are called the Pythagorean identities of trigonometry. Now there's other identities. There's the odd identities, and I hope you remember what odd functions mean. Changing the input value changes the output of the function. So if I have a negative on the angle, that negative might just as well be written in front of the function. We also have even identities for which that does not apply, because I hope you remember that for odd functions, f of negative x is the same thing as negative f of x. However, for even functions, f of negative x, changing the input function, switching the sign of the input does not change the sign of the output. So these are even functions and odd functions. It's important for you to remember the only even functions are cosine and secant. And because secant is derived from cosine, it makes sense that it's an even function. Everything else besides these two is odd. That's how you can remember it quickly. So as we go into practice examples and solving questions, I want to repeat again that solving these kinds of functions is basically figuring out how to rewrite an expression you know in a way that can help you find the outcome that you're being asked to find. It's basically being asked to represent the trigonometric function in a particular way. And if you think about it, what this works on is your problem solving skills, being able to see a situation differently, being able to bring out information that you know in a specific way or in a different way or in a different kind of way that will help you solve the problem, the unique problem that you're trying to solve. So here I'm simply asked to simplify or find the exact value of this function. It's a composite function because you have tangent and secant. Now, if I'm lazy, I can just leave it as it is, but you will not get any points for that. Simplifying it requires me to know, what is tan? Tan is the same thing as sine theta divided by cosine theta. It's being divided by secant, and secant is the same thing as 1 divided by cosine theta. So I can go ahead and simplify this. Sine theta divided by cosine theta multiplied by cosine theta over 1. So cross out the cosines because it's the same, it's basically division, and I end up with sine of theta. So I have simplified this whole function into one simple thing, which is sine theta. And if I was trying to evaluate this function, it would be much easier to just evaluate sine theta instead of having to evaluate tan theta and secant theta. So the problems are like this. I know this seems simple, but this is the basic idea, expressing something you know, how you know it, to help you solve the problem uniquely, right? And there's going to be many ways to solve it. If I felt very cool or high skill level, I could have written tan as secant squared theta minus 1 square root. Where am I getting that? And I could have written secant as 1 plus tan squared theta square root. Right. This just makes it more complicated. The simplest way to do it is this way. This is not wrong, right? I'm just trying to show you that you can use information how you know it. You can use information how you know it to help you solve the unique problem. So this information how I know it this way can help, but it would take much longer, would require a lot more work than just doing it this way. So that's basically the point of this unit, that you can use the information you know to solve or simplify different expressions. Here's another one. It's asking me to find the exact value of each composite function. Well, I know that if I have the sign of negative x, that is an odd function, so that's the same as negative sine of x. The cosine of negative x, that's an even function, so that's a cosine of x. It just stays as cosine of x. In the beginning, you'll have to go back and forth checking what these things are, but eventually with time you get used to it. Cosecant of negative x, I know again that this is an odd function, so it's the same thing as negative cosecant. Negative cosecant of x. I got it right this time. Okay, so negative sine x, I've dealt with the odd even portion of the question. I have a negative here and a negative here. Those two negatives will give me a positive. So positive sine x times cosine of x times, instead of cosecant, I can write it as 1 out of sine x. And then what do you see? I see that sine and that sine can cross out because they're products. This is basically the same thing as writing it as sine x times cosine x over sine x. This is times, not subtraction, so you can cross out the sine x. So, and you'll discover that we'll be using a lot of skills you learned in algebra, and the final answer here becomes cosine x. But I was saying we'll be using a lot of the skills you learned in algebra, things like Pythagoras theorem. completing squares, difference of squares, reducing fractions, reducing algebraic fractions. So yeah, what is the point of all of this, you ask? What's the point of all of this? This is a short question, or a Daniel question, or an all of you question. But I think I mentioned earlier that the point is going to be to kind of help you practice how to piece together different forms of information to solve a problem, right? Because just having information, just knowing that tan is sine over cosine, just knowing it without being able to manipulate it or use it in different scenarios to solve a problem, it's not very helpful, or it's pointless. So the biggest gain that I see from this unit is helping you figure out how to use information, how to manipulate information to solve problems, how to fit information in specific scenarios to help you solve the problems. And that's an important life skill, if you ask me. As far as how this is going to help you buy tomatoes at the supermarket, not quite. Also, it prepares you for further courses in mathematics if you're interested, or physics or science, and just a better understanding of these functions, because these functions are what model things like sound, electricity waves, light waves. So yeah, there you go. Another example, simplify the first expression by writing the simplified form in terms of the second expression. So they want me to write all of this in terms of cosine. Let's attempt to do that. Start with what you know. On the left, in this portion of the first expression, there's nothing that I can simplify or expand, because all of them are stated in their simplest ways. However, tan is not stated in its simplest way, so I can start there. I'm going to write this portion the way it is, 1 plus sine x, and instead of writing tan, I will write sine x out of cosine x. All of a sudden I have I have two fractions which I can add by finding the LCM. I hope you remember LCM is simply the product of the two denominators. So my LCM will be 1 plus sine x times cosine of x. So simplifying this fraction, 1 plus sine x, this whole thing divided by this denominator gives me cosine x. Cosine x times cosine x is cosine squared x. I know you guys do this differently, because I've had some of you say things like cross multiply or divide or etc. So, but the good thing is it's addition of fractions, right? It's addition of fractions. It was taught in 4th grade, so you can do it how it's simpler for you. What I'm basically doing is, if this is k over a and this is p over m, I have a times m, which is my denominator, and I have am divided by a is m times k is mk. That is basically what I'm doing. It's addition of fractions. So yeah. Right, the second part is the same denominator, right? The LCM divided by the denominator of the second fraction. The cosine cancels out, I hope you can see that, times the top. I'll have sine of x into 1 plus sine of x. If this is confusing, you can come in person, then I can try to explain this in a simpler way. Alright, so simplifying the numerator of this new fraction, cos squared x plus sine x times 1 is sine x plus sine x times sine x. So I did this first, I got sine. Now I'm doing this second. I get sine squared x, all divided by, I'm not going to expand this because I can already see something that I will cross out. If you don't see it yet, that's okay. I don't have to panic to cross it out, or I don't have to cross it out just yet. If I need to cross it out eventually. I still have a chance to, but let me just not do it right now, just to see what I have. I hope you notice in the numerator of this expression, I have a cosine squared theta, and I have a plus sine squared theta. If we go back to our set of identities, sine squared theta plus cosine squared theta is the same thing as just 1, right? So where I have sine squared theta, let me just rewrite it. I can write it as sine squared x plus cosine squared x plus sine x. But this whole thing, I'm just going to replace with 1 because that is the first identity, the first trigonometric identity. Every time I say first identity, that's what I'm referring to. This is the first trigonometric identity, and I know that sine squared x plus cosine x is the same thing as 1. If you doubt this, pick up your calculator and punch in sine squared 30 plus cosine squared 30. It will give you 1, I guarantee. If it doesn't, I give you 10k. Make sure your calculator is in the correct degrees. Yeah. Alright, so that's 1 plus sine of x divided by, and I hope you can see what I talked about earlier, that will cross out 1 plus sine x times cosine of x. At the top I have 1 plus sine x, and at the bottom I also have 1 plus sine x. So the two 1s plus sine x's can divide or cross out. Now I'll just be left with 1 divided by cosine of x. I have expressed this first, I've expressed the first expression in terms of the second one, which is what the question asked me to do in the beginning. To express this first expression, this one right here, in terms of cosine, and I've done it. So that whole expression is equal to 1 divided by cosine. So again, using information that you know, I have not used any new information here. I simply made the substitution for tan. That's the only thing I did. Everything else was solving algebra, right? Algebra that you've done in 8th grade, 9th grade, adding fractions that you did in 4th grade. Yeah, I didn't do anything besides just rewriting tan as sine over cos, and I've been able to use that information and the skills I have to show that that's equal to cosine of x. I mean, to write that in terms of cosine of x. Alright, another one. Simplify this expression by writing the simplified form in terms of the second expression. Oh, I mean, if your question was, can I write this as secant of x? Yes, that's fine. I'm also still going to use algebra here. I have two fractions, one fraction, two fractions. I'm going to add or subtract those two fractions. I'll start by finding the LCM. The LCM is going to be the product 1 minus cosine x of the two denominators, 1 plus cosine of x. And then simplifying this, this whole thing divided by this denominator, I'll be left with 1 plus cosine x. Again, if this part is confusing, I can help you, or you can ask any of your friends. And then something, the whole green thing divided by this blue denominator, the 1 plus cosine x crosses out, and I'm left with 1 minus cosine x. But that 1 minus cosine x will be multiplied by what's already on top, which is cosine of x. Alright, moving on. I hope you see that in the denominator of this expression, this denominator is a difference of squares. And just a reminder, difference of squares, if I have a minus b into a plus b, that's the same thing as a squared minus b squared. So here my a is 1 and my b is cosine of x. So that whole thing is just going to become 1 minus cosine squared x. And just I'll keep pulling on this thread. 1 minus cosine x, taking you back a little bit to these identities. If you look at this one right here, the very first one, the first identity. If I look at the first identity, if sine squared x plus cosine squared x is equal to 1, if I were to move the cosine to the other side, then I'll be left with sine squared x or theta is equal to 1 minus, because if I subtract cosine squared theta on both sides, then sine squared theta will be 1 minus cosine squared theta. So instead of trying to figure out what to do for where I'm at in this question, since I see that I have 1 minus cosine squared x, I know that that's the same thing as sine squared x. So instead of this whole denominator, that whole huge thing, I'm going to replace all of it with just sine squared x. So simplifying the numerator, I'll have 1 plus cosine x minus this 1 times this cosine x is negative cosine x, and this negative cosine x times cosine is negative cosine squared x, but because of this negative over here, it becomes positive cosine squared x divided by, wait, am I right? Cos minus cos squared, negative cos plus, yeah, right. So I replace the whole denominator with sine squared of x. Now in the numerator, I have cos squared positive, cos squared negative, those two cancel out, and then I'm left with 1. Wait, am I right about this? Then I'm left with 1. I hope I'm right. 1 plus cosine squared x divided by sine squared x. Okay, they want me to express it in terms of cosecant. Let's see. I hope you also remember, again, algebra, that if I have a plus b divided by c, it's the same thing as a divided by c plus b divided by c. So that's the idea that I'm going to use to simplify this. That's the idea I'm going to use to simplify what I have. So instead of 1 plus cosine squared x divided by sine squared x, I have 1 out of sine squared x plus cosine squared x out of sine squared x. Now, 1 divided by sine squared x is the same thing as cosecant squared x, and cos squared x divided by sine squared x is the same thing as cotangent squared x. Now, taking you back to the trigonometric identities, and again, after you've done them several times, they will become second nature. Which of those identities can I use? I hope you see that this one says cotangent squared x plus 1 is equal to cosecant squared x. So where I'm at here, I have cosecant squared x plus cotangent squared x. They want me to write this whole expression in terms of cosecant x. So I can replace cotangent x in terms of cosecant. So I have cosecant squared x plus, instead of cotangent, this is the same thing as 1 minus cosecant squared x. You see that? So, sorry, not 1 minus, something as cosecant squared x minus 1. Cosecant squared x minus 1. So my final answer is 2 cosecant squared x minus 1. This might sound confusing, look confusing, feel confusing, but it's just going to take practice for you to get used to representing these things differently. What I have done here is, just to recap, what I have done is simply what I have done is simply move the 1 to the other side. I moved the 1 to the other side. I subtracted 1 and subtracted 1 and ended up with cotangent squared x or theta is equal to cosecant squared theta minus 1, and this is what I substituted in place of cotangent. In place of cotangent, I substituted cosecant squared x minus 1, and then my final answer is in terms of cosecant, just as I was requested. So think of this whole process as if you are a spy, some kind of MI6 operative, and you have all of these passports to travel to different countries, and each time you have to go to another country, you change your identity to look like what the passport says, and you go on with that identity, looking like that person, being called that name, yet you're still the same person. So just the ability to manipulate this information, use it in different forms to solve problems, that's the whole point of this topic. Alright, this one, tan x plus cotangent x divided by secant x times cosecant x. I'm going to go fast on this one. Sine of x divided by cosine x, that's the same thing as tan, plus, instead of cotangent, I have cosine x divided by sine x. All of that is being divided by secant, which is 1 divided by cosine x times cosecant, which is 1 divided by sine x. The top expression has a denominator, which is cosine x times sine x, and if I do the division, I will have sine squared x, because the cosine cancels, and I'll have sine squared x plus this is cosine squared x. That's just for the top, and then the bottom also is 1 over cosine x sine x, cosine x sine x. So I have two fractions that are being divided. I'll just do KFC. Keep the first one. Oh, by the way, I hope you saw that in the numerator of the first one, I have sine squared x divided, sine squared x plus cos squared x, which we know is 1, divided by cosine x times sine x. That whole fraction is being divided by 1, divided by cosine x times sine x. If I do the flip and the change, if I flip this, the denominator will go on top over 1, and this is still 1 divided by cosine x sine x. This whole thing is the same as that whole thing, so that cancels out. Number 2 is 1 over 1, which is the same as 1. I have proved or verified that all of this is equal to 1. Yeah, using algebra and knowledge of trigonometric identities. And lastly, verify this identity. The only thing here is squaring. So I'm going to square that. I know that if I square in bracket, that is a plus b squared, it becomes a squared plus 2ab plus b squared. Now I know that you're going to feel tempted to go the long way and do that, a plus b, you will still come to the same answer, but this is going to take you a long time. And at this stage, you should really strive to get to a point where you know what the outcome will be. But I'm not stopping you from going the long way. I just promise that you will come to this same answer. So that's what I'm going to do for this. Sine x plus cosine x close bracket squared is going to become sine squared x, because sine is a, plus 2 sine x cosine x plus cosine squared x. If I rearrange it, it becomes sine squared x plus cosine squared x. I'm grouping that because I know that it's equal to something, i.e. it's equal to 1, 2 sine x cosine x. So this is equal to 1, I'll just replace equal to 1 plus 2 sine x cosine x. Now that is what they asked me to verify, and I've done that. This question will come back when we start talking about double angle identities, but that's for a future time. And this can be simplified further in terms of double angle identities. So we'll see what that is when we get there. All right, this is your homework. Enjoy your homework.